In our video today, we're going to look at solving simultaneous equations by elimination. And before we go into that, I'm just going to go through some basics about equations and kind of explaining why we're doing certain things or why it's allowed before just saying, hey, you're going to do this, and then there you go. If you know all those rules, then just skip ahead to the examples. But yeah, so in this, I have two equations here. One is red and one is blue, but this is not art class. You're not learning colors. We're learning about equations, and both have a left and a right side. And if I took both these equations and I added both left sides, that would be the same as adding both right sides. So if I said 1 plus 2 plus 2 plus 4, that would be 9. And then 3 plus 4 would also, 3 plus 6 would also be 9. So in a column, I could have done it like old school. 1 plus 2 is 3, and 2 plus 4 is 6, and then 3 plus 6 is 9. And then you can see, this works out. And the same if I subtracted. So if I took this total, let's say that's 3, 1 plus 2 is 3, and I minused this side, which would be minus 6, it would be the same as taking this side, which is 3, and minusing this side, which is 6. The reason for this is because these sides are equal. So if I add both, I'm going to get the same when adding the other two, or subtracting both would be the same as subtracting both on this side. Another point I want to make is in this equation, I doubled everything and I got this equation. So 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 is 6. So I basically multiplied every number with 2, or every term. There's a little confusing bit because sometimes students say, well, if they just want to multiply twice on the one side. So they want to do 1 times 2, and that's 2. And then just write the 2, and then the 3 times 2 is 6. And then say, well, these two aren't equal. But I did left what I did right. But the thing is, you didn't multiply everything on the left side. So for example, if you wanted to do this correctly, you say 2 times everything there, 1 plus 2, and 2 times everything here, which is 3. And then you'd see, 2 times 2 times 1 is 2, plus 4 is equal to 6. So it's very important that you multiply or do the same with every single term when we multiply or divide. And then the last point I want to make is in an equation, I can change all the signs, but I have to change the sign of every term and it'll still be balanced. For example, if I change this to a -1, then I'd have to change that into -2 and that into -3. And then now I see -2 minus -1 minus -2 is going to be -3. And that works out. So if I had a different equation, let's say I did something like 5 minus 2, that would be 3. I can, again, change all the signs straight through. So this is maybe a +5, so I change it into a -5. This is a -2, I change it into a +2. And then that one I change into a negative as well. And if I see here, -5 plus 2 is -3. So in an equation, I'm allowed to change all the signs. If you want to think differently about it, it's just saying, well, I moved this one that way and it became a negative, and I moved this one here and it became a positive, and I moved that one there and it became a negative, and I just looked from the other side or just rewrote it differently. But anyway, so that's the basics that we need to understand about equations and why they work. And let's jump into some examples of elimination. Now, as you remember, whenever I have an equation like this, I have unlimited amount of solutions because I have two variables. So this can be 1 and 5, or it can even be 3 and 3, or it can be 10, -4. Unlimited amount. But as soon as I have another equation, I'm actually able to solve them. Now, in this case, you can do substitution with this, no problem, but we're going to look at elimination in this video. And what I'm going to do is I'm just going to add everything on the one side and add everything on the other side. And we're going to see some magic trick happens, because x plus x is going to be a 2x. And this is a -y plus, a plus y minus a y. So plus y minus y is going to be 0. So this is just going to be 0. I don't have to write the 0. I'm just showing, hey, those two add up to 0. And then 6 plus 4 is 10. And now I have an equation, 2x is 10. X, therefore, is 5. So what happened here is when I sorry, excuse me. What happened here is I kind of added these two, and luckily for me, their signs were different. They had both one y's in front of them, and they cancel to 0. You can imagine later on it's not going to be that easy, but the principle still stays the same, that I can add the left and right sides and I can get to answers. I'm not done yet. I just got the x value, so I basically have to sub in. I can choose any equation. I can put 5 in there or in there. I'm going to do the top one. So 5 plus y is 6, and we can see y is going to be, well, 6 minus 5 is 1. Okay, so let's take a look at just another example. I'm going to do a lot of examples. Obviously, repetition is how we learn and become better at math. Okay, so 2x minus 3y is negative 8. Like the color is 5x plus 3y is negative, well, no, just a 1 is fine. 1. Okay, so in this example, I can see the x's are nicely lined up and the y's and the constant numbers, so this is very nice. And again, conveniently, we have a negative 3y and we have a positive 3y, and we can see if we add those up, they're going to be 0. So I'm just adding up normally from left to right. 2x plus 7, so 5x is 7x. These are going to cancel and will be eliminated. And negative 7, plus 1 is good. I'm thinking about the answer before actually just reading. Let me try again. Negative 8 plus 1. That's negative 7. So I'm going to divide by 7 on both sides, and then I get x is negative 1. And now I can sub that in any of the equations. Let's do a nice color-coded version, not go too quick. And that's negative 1, that x over there, and the rest of my equation. And that's negative 8. And then 2 times negative 1 is going to be a negative 2, negative 3y is negative 8. If I take this over, it becomes, or I add 2 on both sides, I'm going to have negative 3y is negative 6. And just divide by negative 3 on both sides, and then y would be equal to 2. Okay, so always remember, once you have the 1 and you're so happy about this elimination, don't stop there, actually finish and find the other answer. But in the Cambridge exam, it would usually you would probably not forget, because it would say x equals dot 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 on the paper, and y equals dot dot dot. So you'll fill in and you'll be like, oh, I remember. So that's quite nice. Anyway, let's take a look at an example where it's not as straightforward. We're going to go up gradually so that it's not too much. So let's do 4x plus y is negative 1. And I'm going to do a different color again and say 7x plus y is negative 4. Now in this case, it looks very similar to the previous one. We have the x's lining up and the y's lining up and the constants. But we have a bit of a problem. If I were to add these two, if I said 4 plus 7, I'd get 11x. And a y plus another y, I'd get plus 2y, and this would give negative 5. Now this is not really helping me because I didn't eliminate any of the variables. So these two look similar, and they're actually identical. In the previous examples, we had a plus and a minus, but now we have both plus. So what we need to do is we kind of have to do a little trick, and we change the signs of this whole equation. I can choose either one, doesn't matter. I'm just going to choose this one because it's closer to where I'm writing. So the 7x, I'm going to make negative 7x. This plus y, I'm going to make negative y. And this minus 4, I'm going to make plus 4. And I'm going to work with these two equations now. And let's just keep this color, little line there. So I'm going to ignore this one, going to kind of draw a little line there. And what I'm going to do is going to say 4x minus 7x, that would be negative 3x. And see what happens here. We have a plus y and negative y, and they reduce, or they cancel out, eliminated. And you have negative 1 plus 4, and that would just be a normal 3. And now I have negative 3x is 3, so x is going to be negative 1. Again, not finished. I can sub this into either, I can actually sub it into this one, or this one, because yeah, that's fine. These two are the same. Maybe let's do this. Let's kind of prove that left is equal to right, and we'll do it in both. Let's do it in both and just show 4x. So 4, I'm going to put in the -1 in there. I should have done a different color. Anyway, -1. So here I have -4 plus y is -1, and then y is going to just be 3 in this case. And let's just sub it in there and see if we get the same answer. Let's do the blue. So -7, and I put in a -1, and then this is a y is a 4, and then here I'm going to get, well, +7 minus y is 4, and I'm going to move around, and 7 minus 4 is 3, is equal to y. Basically just added the y on both sides, so that the y moved that way, and I subtracted 4 on both sides. And here you can see, well, it's the same thing, because these equations are the same. Okay, so important bit here is when these are the same signs, we're going to have to kind of subtract them. Okay, I think that's enough for this video. In the next video, we're going to look at a little bit more tricky examples. I just don't want to make too long videos because, you know, that's boring.